So there's this groundbreaking study focusing on a protein that's basically a protector for hair follicle stem cells. It's
Yeah.
called MCL1, and it seems to be a key player in preventing hair loss during regrowth.
Right, so if I got it correctly, MCL1 kind of acts as a safety shield for these cells when they're under stress?
Exactly. It's like during hair regeneration, when stem cells activate, they incur a lot of stress and DNA damage, which triggers pathways, like P53, that can make the cell self destruct if there's too much damage. MCL1 quietly steps in to balance those survival signals.
Interesting, so even though the hair follicle cycles normally when the cells are dormant, it's really during that active phase, right?
Yes, right on the mark. When cells are actually waking up to regenerate hair, they're vulnerable. Without MCL1, they mostly end up dying due to the stress induced damage. That's what leads to conditions like alopecia, where the follicles essentially
Yeah,
get shut down over time.
and the study mentioned that if MCL1 is removed, the hair growth eventually becomes compromised, even if the follicles initially form just fine.
Precisely. It's a bit like the cells have a delayed tipping point. It appears later in life. Initially, things work normally, but once the stem cells get activated repeatedly, the cumulative stress without the MCL1 safeguard causes them to just, well, self destruct.
That's pretty striking. Now, what about this ERBB pathway? How does that factor into MCL1 regulation?
Good question. The ERBB pathway actually ramps up the production of MCL1. So if that signal is dampened or blocked, MCL1 levels fall, and you're effectively leaving the stem cells unprotected. It's like having a faltering support system for your cellular safety net.
Yeah, so if the booster for MCL1 is off, the hair regrowth engine just stalls, huh?
Exactly. And here's a twist. The researchers found that reducing levels of another protein, BAK, which normally promotes cell death, can rescue hair growth even without MCL1. It's this delicate tug of war where lowering the death signals can somewhat compensate for the loss of the protector, at least in the hair follicles.
Wait a minute, so tweaking these cell death proteins could, in theory, override the absence of MCL1? That's pretty interesting.
Yeah, it's almost like giving the cells an extra chance, a sort of safety net. But I do have some reservations. If we're reducing cell death mechanisms, could that not risk leaving damaged cells around and possibly contribute to, say, cancer elsewhere?
Yep, exactly. That's what I was thinking. Balancing cell survival and the natural cleanup is tricky business.
For sure, the goal seems to be protecting these stem cells just long enough to repair themselves without disabling the body's quality control, like the P53 guard. So future treatments might focus on a very targeted, short-term boost to MCL1 or modulate the ERBB pathway to make sure the cells survive their stressful moment of activation.
This really could shift how we look at treating alopecia, moving beyond just symptoms to addressing the root cellular vulnerabilities, right?
Absolutely, and the broader implications are super exciting too. Think about it, as these survival strategies might be at play in other regenerative tissues or even in managing cancer. It's like unlocking a hidden code in cellular longevity
Yeah,
and regeneration.
definitely promising. I can't wait to see how this research evolves into more refined treatments that, make a real difference for people facing hair loss.